Today in Capetri's Corner, we're going to look at scatter plots and lines of best fit. So right off the bat, we're going to go over some vocabulary. So a scatter plot is exactly what it sounds like. It's a bunch of points kind of scattered all over. What it is, they're data points. So when we try to draw a line of best fit, it's exactly the way it sounds. It's a line of best fit, not exact. So when I draw a line through here, I'm not going to hit all the points, but I'm pretty much in the middle. That's what I'm going for. Okay. So what this says is as the hours after sunset increases, right? So as this goes up, the temperature decreases. So when that's the case, we're going to say that's a negative correlation. As one goes up, the other goes down. Also, if you just look at the line itself, that's a negative slope, upper left to bottom right. If you look at the next example, I can draw this line. It would be somewhere in the middle there. And in this case, as my X increases, right, as this goes up, also my Y is going to go up. So we're going to call that a positive correlation. Okay, if you look at the last one, there really is no line of best fit or no trend. It's just kind of all over the place. So we're going to say that that's no correlation. They're not related at all. Now, to save some time, what I did was I looked at some things we already did, finding slope, using point slope, and I just kind of wrote it out early so that we could save a little bit of time and we can concentrate just on the scatter plot and line of best fit. So in example 2, it says the table and scatter plot shows the average cost of a jet boat in the years after 2000. Write an equation to represent the data. Then use the equation to predict the cost of jet boat in 2005 and 2025. So again, as we're looking, let's take a look first. Look at the line of the best fit that was already drawn for you. That is definitely a positive correlation. So what that means is, as the years go up, as years go by, the cost of these boats costs more, which makes sense, right? So when we're trying to find a line of best fit, you're not these data points were all used to plot the points for you. We're not going to use them necessarily when we're writing our equation. We're just going to look at the line of best fit. Okay. So what I did was I tried to find the best I could the line where it goes through the corner of the box. So I found one here, right there. That's pretty much through the corner of the box. So that's the 0.1 and 20,000. And then the other lot point I used was up here. Now, again, it doesn't matter that the point is there. I'm looking just at the line to see where it goes through the corner of the box. And that's 11 and 35,000. Okay. And again, that's year since 2000. And that's also the cost in dollars. Okay. So first thing we have to do to write an equation of alignment, we have to find the slope, which is what I did here. Right. And then that simplified to 1500. That's what the slope is. Okay. Then I used point slope. So I use this point. You can use either one as discussed before. And I substitute that into my formula. Here's my equation of the line. Okay. So that's the first thing I needed was the equation of the line. Now from there, I have to plug it in. So again, 2005, that is 5 years from 2000. So I took the equation, the line of best fit, and I substituted that 5 in. And when I calculate that, I get 26,000. Okay, that's how much that boat's going to cost. 2025, again, that's 25 years. 25 years from 2000. So again, I substitute that in. And obviously, we were expecting that to be more. That's going to be a lot more because it's a lot of years there. $56,000. Okay, so that's what happens in line and best fit. Once you plot the points, you find the line of best fit. You find the equation of the line. Once the points are plotted, and then you draw your line of best fit. You don't look at the points, you just look at the line. And then we use that equation to predict in the future. That's really what a lot of businesses do. Okay, example 3. This table shows the amount of time required to download a 170 gigabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the file if their internet speed is 800 megabytes per second? Okay, so the first thing we did, again, all these points are plotted. We didn't have to do that. That was done for us. So, and then we have a line of best fit here, right? This one's kind of up there. It's a little bit of an outlier. So it's not really with the trend line. So we have the line of best fit there. And then what happened is they gave us points that are on the trend line. So we're just going to use those, right? So I didn't have to find them in this case. They came up with it. They show it to us. So we're going to be like, fine, we're going to just use them. Okay. So again, in using those points, I'm going to find my slope, which is negative 1 over 52. Use my point slope. And I get this equation here, which is definitely a little bit tricky using those fractions. But again, it's a real life problem. So in the end, if we need to round to a decimal, we will. But that's the equation that we're going to use. Now, the next part of this problem says use the equation of linear model to find the y value that corresponds with x is equal to 800. So it's saying use this equation. And we're going to try to figure out when x is 800. So I'm going to get negative 1 over 52. I'm going to multiply that by 800. And I'm going to add 210 over 13. So basically just substituting that 800 there. Now we get a fraction, which is what we talked about, right? We get a fraction. So in the end, we're going to say the y value. I'm going to change that to a decimal because a fraction isn't really going to work in this particular problem. So it's going to be 0.77 minutes. So what does that mean? So let's go back to what our labels are. When the internet speed is 800, it is only going to take less than a minute, 0.77 minutes to download. And that makes sense, right? As the speed increases, the time is going to decrease. Okay? All right, so let's look at the next thing. It says, what is the x-intercept of the trend line, right? And again, is this possible? So we know, like if we were to graph something, right, if this continues, my x-intercept is when y equals 0. So I took the original equation, substituted in 0 for y, and then solved it. So in the end, x is equal to 840. So our point would be 840 and 0. So it says, is this possible? So I'm going to say yes, that's possible, right? As the internet speed increases, the time decreases. Now, will it ever be 0? Well, it's hard to say for sure, but I would think yes, there could be some technology coming up where it's going to take no time at all. So as the internet speed decreases, maybe at that point it's going to be so fast that it's instantaneously, or it's going to take, less than a second. So we're just going to kind of round that to 0. Okay. Thanks so much for stopping by today. You have a great day.